just so we can look at it. All right, can you see it?
I can.
Okay, so you're trying to figure out what point is missing from the red shape is basically what it's asking you. What are they calling that point? Point S. So we know by looking at the blue one that it's going to be, I don't know, somewhere around in here. We don't know exactly, but that would make the shape, well, I didn't do a very good job estimating. Maybe be a little further over this way, but somewhere in this area to make the shape similar to the blue. So you look at your options. 4, let's see, 2, 4, 2, 4. Well, if you go over 2 and up 4, that's going to put your point up here somewhere. That doesn't make any sense.
Yeah.
4, -2. 1, 2,
That's
3,
not
4.
right because that goes far right.
You're correct. So see, you can eliminate those two right from the start, which is pretty helpful, even when you're taking standardized tests to think that way. So then we have these others that are in this quadrant because they're negative. So it could be either of those. The way you tell which one it is because of the scale factor. So you've already got some points you can match up, like Q and K are corresponding points, so you can compare them. Let's see, Q is 1, 2, 3, 4, 5, 6, 7, 8 is -8, 0. I just counted on the grid. And K, somehow it changed to point K, or K changed it, and K is 1, 2, 3, 4, -4, 0. So what happened to get, let's go the other way, from K to Q? What did they do?
They doubled it.
They doubled it. So that means our scale factor is what?
Let's see, 8, -8.
No. If they doubled it, you said they doubled it, that means they multiplied by what?
By 2.
Yeah. So that 2 that you multiply, that is the scale factor.
Okay.
Scale factor is just what are you multiplying by to change it?
By 2.
So now we want a point that goes with M so that we can figure out what this is down here. So M is, let's see, -1, -2. Again, I just counted it on the grid. -1, -2. And we want to change it using this scale factor. What are they calling this new point? Point S. So what's point S going to be?
Let's see. The negative something, right? The -4.
We're going to use the scale factor and multiply times each.
So -2, -4.
Boom. You got it. That's option C. And look at what option D was. If you had to put your coordinates in the wrong order, you might have thought it was option D. So be careful with the order of your coordinate.
Number 15. Figures. Well, let me try to figure something out.
Okay. While you're working on it, I'll get it on the screen just in case. Oh.
Was it rodeo or night? How do you know?
All right. What you got?
Well, I see with the point on A at the far right,
Mm-hmm.
scale factor is wrong.
This one?
Maybe it
And
was a
then
girl.
compare it with the one.
This one?
Mhm.
You're right. The scale
Yeah.
factor is different.
I think
So
1,
if
2,
this
3, 6. But it's 8, 3, 3.
You got it. So if the scale factor is different on any of the 3 points, what does that mean about the 2 shapes?
Then they're not the same.
Right. They're not similar.
They're not so. Yeah, they're not similar.
Mhm. Because the scale factor is telling us that proportionality word. The scale factor is describing that, how the proportion works.
Mhm.
And if the proportion doesn't work, they're not similar, because that's kind of like a rule for being similar.
Okay. All right.
Good.
Figure out 17.
Okay.
All right. Okay. So 17 is a reflection.
It is. Very good.
And then when's the quiz? Or is there like a quiz coming up on this?
We have a test. It was going to be Monday, the test was. We were going to just do test review, like the practice test thing in class on Friday, and then have our test Monday.
Mhm.
But I think I'm going to make the test be Wednesday
Mhm.
so that Friday I can make sure y'all understand 6.5 and 6.6. And then Monday we'll do test review, and then Wednesday have the test.
Okay.
So we might do like a classwork kind of quiz thing, but it'll just be a classwork grade where y'all can use your book and stuff like that.
Okay. Looking at 19 right now.
Okay. I'm going to share. I got the whole textbook page now, so I'm going to put that up instead of the smaller one. All right. Can you see that?
I can. Yes.
Okay. That way I can scroll through the whole page.
All right. So the scale factor of 19 is 2.
Uh-huh.
And they don't know M and N. N is 5 and M is 4.
M is 5. M is 4. I believe, yes, you got it.
All right.
Very good. That was quick.
Mark that down.
Other people are dollars.
All right. If you have a dilation, scale factor, right? Think scale factor.
Mhm.
So for this one, the scale factor, it says ABO is a dilation of DEO. So you started with the blue and it turned into the red. So did it get larger or smaller?
Oh, they got larger.
Larger.
Mhm.
So your percentage has to be more than 100%, because 100% would be if it was the exact same size.
Uh-huh.
So
So
we can get rid of those two, right?
So that said, I think it's going to be C, because if it was 200%, then it'd be double the size.
You are very correct. Good job.
Awesome. Okay. There were a few other problems. I can't. What were they? They were
I have to look at the list myself. I skipped around. 25 through 29. Yeah. Let me get the next page.
And number 25.
I'm pulling up the next page.
Okay.
Maybe. Oh, it's supposed to be.
Girl always want the
What happened?
food.
Oh, there we go.
Get those rocks. You'll leave it though. Okay.
All right. All right. This is similar to that one with the little picture sticker question.
Okay.
Each advertisement. Oh, so sorry. So that it fits in a 12 by 6 inch rectangle. For my brain, it just helps if I can see that. So I'm going to draw a rectangle and label it 12 by 6, just so I can kind of picture what they're talking about. The agency uses a scale factor of 24. So scale factor 24. To enlarge to create the billboard. What dimensions is it in feet? All right. So a scale factor, remember, is going to be multiplied,
Mhm.
or if you're reducing the shape, it's going to be divided.
Uh-huh.
Let's see. Let me make sure I understand how they're explaining this. Scale factor 24. Oh, okay, got it. I was looking at their answer and I'm thinking, this is not right, but I get it now. Okay. Inches and feet are very important. That's what I wasn't. Okay. So this 12, I'm going to put the little thing like this for inches. The 12 and 6 are in inches. So let's work with inches first, and then we'll worry about the feet thing.
Okay.
So 12 inches, I mean, that's pretty small, right? Like it could fit on your desk. A billboard obviously could not fit on your desk. So first we're going to change it to inches. So it'll be a whole lot of inches, and then we'll convert it to feet. So it'll be a little bit smaller number. But scale factor just means we're going to take this rectangle and make it enormous to fit on the billboard.
Okay.
So you're going to multiply each dimension by the scale factor.
Okay.
So of the billboard, which this is obviously not as big as it's going to get, but let's say that this is the billboard. How wide is the billboard going to be if your scale factor is 24? That 12 is going to become what?
A foot.
Not yet.
Oh.
Multiply by the scale factor first. So 12 times 24.
Okay.
Did you get 288?
Yeah.
You didn't? What's wrong, Grace?
Okay, so 288.
288. Okay. What'd you get for the 6 changes to what?
See.
Where's your water, Cruz? Can you get your water?
144.
You got it.
Right.
Yes, 144. All right, so that's inches. But if we want to change it to feet, how many inches are in a foot?
12. So
12.
And 288 divided by 12.
You got it?
Let me grab my
Which might,
real quick.
yeah, you might be mad at me for the answer, but I want you to understand why it's the answer.
Sure.
Get his water cup, Max. It's the red one with the blue top.
Mom,
Yeah, Cruz.
this one?
Yeah, you can give him that. You want your milk?
Yes.
Tell Max thank you.
Thank you, Max. You're welcome. We're running, Dude, that's full.
Food all over your shirt, bud. You got it, Jake?
Yes.
Hang on. So 24 feet by 12 feet.
You got it. I told you might be mad at me for the answer because the 24 came
Yeah.
back to us, but I wanted you to understand why, because this is in feet. The actual billboard would be in feet. But first you get the inches because you have to use the scale factor to get the inches.
Okay.
But that's a real life thing when people use blueprints or some kind of smaller scale thing, like scale cars and scale model cars and stuff like that. So, Max, put this back, please. Max, put this back, please. All right. You working on 26?
No.
Mom.
Oh no, they messed it up.
Yes.
All right, so did you get started on it?
Do you see George?
Yeah.
Hey, bring me a paper towel real quick. I got milk on my computer.
3 inches and 1.5 inches.
Mobile.
It wants the scale factor.
Okay.
So that might be the right answer to the wrong question.
Okay.
All right. Let's see.
2.5 maybe? I don't know.
Don't get frustrated. Let's look at it. So you're doing the
Mom.
you're making a postcard,
Now.
and here's your poster.
Mm-hmm.
The image is 8 inches by 6. So that's going to be, again, I told you, it kind of helps my brain to see it there.
Mom.
This is 8
What?
by 6. The picture on there. The image, it can be 5 inches wide. What should you use for, sorry. This 8 has to change to a 5.
Mm-hmm.
what scale factor should you use?
1.5.
8 times x equals 5. All right, right now, you can kind of think of these as coordinates because that's what we've been working with, right?
Mm-hmm.
So we're trying to figure out how can we change this so that the first number would be a 5. So what did we do to get 5? Does that make sense when I write it that way?
Not really. No.
No, it doesn't. It's okay if it doesn't. I can explain it a different way. All right, every time we've been using scale factor, we've had these coordinates. Let's say just 0, 1, and it became 3. No, you can't do that. It became 0, 3. And we thought, oh, okay, we're multiplying by 3 to make that happen.
Mm-hmm.
You always multiply by the scale factor to change your coordinates with dilations.
Mm-hmm.
So in this question, they're telling you, okay, we want this 8. Right now it's 8, but we want it to become a 5.
Okay.
So 8 times what can equal 5? I have no idea, right? That's a weird multiplication fact that I didn't learn.
Yeah.
But I can solve this problem because I know how to solve for a variable.
Mm-hmm.
If I wanted to get that question mark by itself, what would I need to do? Right now, 8 is multiplied with that.
Mm-hmm.
How do you get that 8 to go away if it's multiplied?
I have the tablet. What?
Think about it this way. 8 times x equals 5. How would you solve for x?
Mm-hmm. Divide by 8.
Yeah, because that'll make those cancel, right?
I got 6.25.
That's the scale factor. All right, let's walk through it again to make sure you understand why we had to do that, because it's a weird way to work to get this answer, but it's right. It's just kind of weird. So your original picture, the dimensions on this, where the pottery is over here, it was 8 wide and 6 tall.
Mm-hmm.
But they were trying to reduce it so they could send out some postcards, so they needed to make it smaller.
Mm-hmm.
And they knew that when they made it smaller, instead of this, it had to be 5 inches wide.
Mm-hmm.
And they don't care about the height. They just know it had to be 5 inches wide.
Mm-hmm.
So how did they change 8 to 5? They had to multiply by something.
Uh-huh.
So 8 times something equals 5. That's how we do to set it up that way. It is a little tricky, but does that make sense?
Mm.
Mom. Mom.
Mm.
Mom.
Yes, no, maybe.
Mom. Papa. Mom.
Cruz, Daddy's helping you. Alex got all this out. You ready for 27, or are you still thinking on 26?
I'm still thinking. I just don't know anything about 26 except 5.
All right. Let's start over. Let's redo the whole thing without my kiddos yelling mom every second. Maybe that'll help too. All right, I'm going to erase. This is the first time we ever saw this problem. I don't even know what this problem says. Hey, look at that pretty pottery. Okay, we're going to pretend like it's all brand new and make sure that we're with it. I'm erasing this stuff too, so we'll have room to write without it being confusing. Okay, so we know what scale factor is just before we start the problem. Scale factor tells us, it describes a dilation. It tells us the number we're going to multiply by in order to change our shape. Good with that, right? Okay. So now, let's see what this pottery is all about. Your pottery is used on a poster for a student art show. You want to make postcards using the same image. So we're caring about the photograph up here, not the whole poster, just the photograph. On the poster, the image is 8 inches in width. So it's 8 and 6 inches in height. If the image on the postcard can be 5 inches wide, so now here's our postcard we're trying to make, and it can be 5 inches wide. What scale should you use for the image on the postcard? So remember scale, they're just saying scale, but they mean scale factor. Tells us how we changed these numbers from the poster to get these numbers on the postcard. So what did we do to get from 8 to 5? Because it's a scale factor, we know we multiplied by something. Because scale factors, you always multiply by something. So kind of in the algebra way of thinking, you can say 8 times something, so 8x, equals 5.
Oh, yeah.
You with me so far?
All right, yeah,
So far, so good? Or do you have questions so far?
6.25 is your scale factor.
Yeah.
All right, let's see.
So that's all. You're done. That's all they want is the scale factor. On a lot of these problems, they've been asking you to find like, okay, well, what would 6 change to? But this problem didn't ask that. Because you have the scale factor now, you could, but it didn't ask us to. All it wanted was the scale factor, which you could leave it as 5/8, or like you said, you could do 0.625. That would be okay too.
Okay, so 6.25 is
not 6.25. It should be
1.65. Yeah.
There you go. A big difference between 63 cents and $6.25, right?
All right. Number 27.
Okay. Let's see. Walking, flashlight. Again, there's no picture. So for my brain, I like to have a picture to figure out what's happening. I'm going to get rid of this postcard stuff up here so I can have some more room.
Okay.
Okay, so you're walking with a flashlight, some people. Let's see. You point a flashlight at your friend, and your friend's shadow is cast on the building behind him. Oh boy. Okay, this is going to be really messy, so I can figure out what I need to draw. So here's your friend, here's a building, and here's the shadow behind him, okay? Let's see. The shadow is an enlargement. Okay, so your friend is getting enlarged to that shadow and is 15 feet tall.
Okay.
15 feet. Oh, can't write a 5 for some reason. 15 feet is the shadow. Your friend is 6 feet tall. What is the scale factor of the enlargement?
Is it 0.4?
if it's an enlargement, what has to be true about your scale factor?
Gotta be greater than 1.
Yes.
So that's not it.
You got 2 numbers to work with. Which one goes on top?
15. No, 6.
Yes.
Yeah, 15. Yeah.
15, because it's an enlargement, put the larger number on top, right?
So it's a 2.5?
Yes. That work.
Okay.
I was just going to make it leave it as a fraction. That was my hesitation. You're not wrong. I was just going to leave it 5/2.
All right.
Does that one make sense?
That does make sense, yes.
It was my amazing art abilities that helped you, right? All right.
Okay, number 28.
28. All right. This one's just kind of a make you think to figure out what could have happened here. I mean, you see designs like this all over the place, and they are dilations. So what do you think that these this artist did to make this dilation?
Well, he could have started from the center, enlarged it by 1.
Mom.
Is it by 1? Look at the
2.
match up your I didn't have my pen tool, sorry. Match up your vertices. So this point changes to here. So it changed from 2 to 4.
2.
Right? So it was enlarged by 2.
Yeah. So scale factor is 2.
Yeah.
Just the answer. You can just say use a scale factor of 2.
That works. Uh-oh. I didn't mean to click on something. Okay. Yep.
All right. And then last one. 29. ABC is vertices.
Mom, I'm a Popeye. I'm a Popeye.
Draw dilation.
Popeye.
You got a Pop-Tart. That's right. All right. This one is like, let me see what one, if you need to look back to. The first part is part A is kind of like example 1, where you're going to list out these coordinates and then use your scale factor to change them. So you need 2 lists.
Okay.
Let's see, I'll do that over here. A, B, C. So list your originals.
Okay.
And then we're going to change them. I'm sorry, that first number got all jumbled. All right, when you use the scale factor 2/3, what does point A become?
Point A becomes, what's the scale factor? 1/3, so 2.
2 is your X value. What's your Y value?
I think I was doing this in my head. Is that it? -2?
Mm-hmm. Yes.
Okay.
Okay, so 2, negative 2.
Mm-hmm.
And then we got a 3 again, so we know that's going to be 2 because 3 times 2/3.
Mm-hmm.
What's 6 times 2/3?
Four.
We got a 6 again, so I'm going to go ahead and put a 4 right there. What's 15 times 2/3?
Yeah. Is that right? 10?
I'm sorry, you may have said it, I just didn't catch it. 10. Yes, that's right.
C coordinates is 10, 4.
So there's your new set of coordinates. That's your dilation.
Mm-hmm.
If your scale factor was 2/3, did it get larger or smaller?
Larger. No. Yeah, larger. No, it got smaller.
Smaller, right? Because your scale factor is less than 1.
Uh-huh.
So I'm going to get a piece of graph paper on the screen.
Okay.
But what you need to do now is graph those two things. And if you have color pencils or something, you can graph them in different colors.
Uh-huh.
That kind of makes it easy to compare them.
Me right now.
Let's see.
So just go ahead and just graph those two things.
Yes, graph those two. That we're still doing part A. I know it seems like a lot, but what happened? Sorry, I'm getting the graph paper, but I have to get it so I can write on it. All right, so when you graph those points,
Mm-hmm.
you have you done it or are you still working on it?
I'm still working on it.
Okay. I'll do it then without talking and then we'll compare. I'm going to do the original shape in blue and then I'll do the new one in red.
All right.
Yeah, buddy.
Mom. Mine. Alice on mine.
All right, you got them?
I do.
Okay, yours look something like this.
Yes, exactly.
Excellent. All right, so that all that was part A.
Mm-hmm.
Part B, find the ratio of the perimeter of the image to the perimeter of the original. How does the ratio compare to the scale factor? Well, here's a hint I've already told you. how their perimeters compare, but we can check it to be sure. The perimeter of the image, remember, image is the second one because it's how it's changed. So the red is the image.
Mm-hmm.
What would the perimeter of that one be? Two of the sides you can count. 1, 2, 3, 4, 5, 6. 7. So 6. How can I find the length of the third side?
The length of the third side. This is for C.
What's that?
Is this for like part C in the problem?
No, I'm still doing part B. But in order to find the perimeter of something, you have to know all the sides, right? Because the perimeter is the length of all the sides added together.
Like all the units. Okay, so I get it. Okay.
Yeah. So the left side there, I counted. Oh man, I counted, and it's 6 long. The top here is 8. How do I figure out that third side?
Oh, I see what you mean. Is it? Let's see. I don't know.
I'm giving you a hint on the left.
Mom.
Oh yeah.
Mom.
Distance formula, right? If they're slanted on the graph, you have to use the distance formula to figure out how long that piece is.
Mom.
Not right now, Cruz, okay?
Mom.
So in your first parentheses, you have x minus x, so 2 and 10. In your second parentheses, you have y and y. -2 minus 4. Are you with me or no?
I'm confused.
Okay.
Oh,
I'm
that. Okay.
I'm trying to find this length right here.
Mm-hmm.
And because it's slanted on the graph, you can't just count it.
Mm-hmm.
Because it doesn't exactly follow the grids. Because, I mean, this little thing, I don't know how long that is. And that's part of it. I don't know how to count from here to here. There's no way to count the boxes. So you have to find the distance from this point to this point in order to know the length of that side.
So is it -64 plus -36?
Oh boy. One more time. What?
-64 plus -36.
-64. It wouldn't be negative. They'd be positive. Because when you square it, it makes it positive. Because it'd be -8. But that whole thing is squared. So yeah, 64 plus 36. Take the square root.
So 100.
Uh-huh. So this side is
50.
Oh, square root. Not divide by 2. Be careful.
Okay. 10.
There you go. All right. So now of the red triangle, the image,
Mm-hmm.
you know all the sides of it.
Mm-hmm.
So what's the perimeter?
So 10 plus 9 plus.
Not 9. It's a 6. Sorry. My writing's wrong. It's all scribbly. The top's a 8 and the side's a 6.
Oh, I'm looking at the wrong one. Okay, hang on. Oh, okay, I see. Okay. So 18 plus 6 is 24.
You got it. So the red perimeter is 24. All right. Time for the blue.
Yep.
2 of the sides of the blue you can count.
So the left side is 9,
Okay.
and the top side is 11.
11. All right. I'm going to give us a shortcut to not use the distance formula again.
This is 13, I think.
Maybe. Why do you think it's 13?
I guess.
It was a good guess. But let's make sure, let's see if that's right. You can use scale factor. If these are similar triangles, which we know they're similar, remember we used the scale factor of 2/3? So 6, 9 times 2/3 is 6. 11 times 2/3 should be 8. So something times 2/3 is 10. Multiply by the reciprocal. This is not making it easier. I was trying to make it easier for you. Scratch that. I don't want to confuse you. It's not making it easier. It's making it harder. All right. Let's do distance again. We're good at that. We've been doing it since chapter 1. Let's see. 3. -3 is this point. You got to know your points to plug in. And point C is 15/6. Plug them in, plug them in. So in the first parentheses, what do you put? Top left is where I'm writing. If you weren't following, sorry. What do I put in the first parentheses?
Let's see. I don't know.
Your x's. X minus x.
Okay. Let's see. 15 minus 3. And then 6 minus 3 minus -3.
6 minus -3. So it becomes a plus in there.
9.
9 squared. And then 144. Did you say 144?
Then we add those. We square that.
Square root.
Then you get 15.
You got it. So this side is 15.
Yeah.
So what is the perimeter of the blue?
35.
All right. The question in part B says, find the ratio of the perimeter. So we found the perimeters. Now we can find the ratio. And they want of the smaller to the larger. So 24 over 35. If you reduce that, what is that?
You reduce it.
What's happening?
What goes into that?
What? Thank God. What? 14, 24, 20, 35. What in the world? What did I do? -2. What? -2, 4, 2. I'm making sure this is where I'm supposed to be. 10, 2, 4, 6, 4. This is not 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it's 12. That was the problem. I was like, these numbers are not going together. Counted the side wrong. I was thinking, I know we did this problem right.
The perimeter is 36.
There you go. Now we can reduce it.
Okay.
There's one list. No.
Divide by 12, so it's 2/3, right?
Yep.
What was our original scale factor?
I don't remember.
In part A.
Yeah. Yeah, 2/3.
Yeah. So the scale factor stays the same. When you do perimeter, the scale factor stays exactly the same.
Okay.
Area, just because I need to get off the computer, so I'm just going to tell you, but area, when you find the area of triangles, 1/2 base times height, right?
So, what's the base?
So for the red, the area would be 1/2 6 times 8.
Okay.
Right? For the blue,
6 times 8 times 0.5. Area is 24.
For the blue, you'd have 1/2 12 times 9.
Times 9 times 0.5. 54.
54. Okay. So let's do that scale factor and then we'll call it quits. So we have small, I forgot to circle it, sorry. Small to large. So 24 to 54. I'm in green over here because I'm running out of places to go. If we reduce that, not 2/3, be careful. You can divide both by 6. So it'd be 4 ninths. So now our scale factor has changed. It went from this. Our scale factor all along was 2/3. But then it changed now to 4 ninths when we did the area.
Okay.
What happened was it got squared. When you do the area, you have to square the scale factor. Scale factor gets squared. The reason is because area is squared, right? Every time you tell area, you say, whatever feet squared, whatever inches squared. So because the area is in square units, the scale factor has to be squared as well. You feel okay about that one?
I think so.
I rushed through that last part.
Squared?
Yeah, you square it.
All right.
So it's 4 ninths, which we found. It's 4 ninths up here.
So 0.4. 0.04.
No, 4 ninths. 4/9.
That's the answer?
Yep. That's
Right.
the scale factor. And then
Okay.
the how does it compare? It's you squared it. You squared scale factor.
Oh, okay. All right.
All right. We like I said, tomorrow we'll kind of do a catch up on 6.5 and 6.6. Make sure everybody's on the same page with those. Then we'll review Monday and have our test Wednesday.
All right.
All right. Thanks for coming to Math Lab, Jake, to understand a little better. I hope it helped.
Okay. Yes, ma'am.
See ya tomorrow.
Yep, you too.
Bye-bye.